Hello everyone, welcome to the Data Journey YouTube channel. In this video we are going to see 5 project management frameworks that you can apply to your machine learning and data science projects. Although some of them are widely used throughout other types of projects, such as software engineering projects, it will be useful to get to know their definitions and knowing how they are different. So we'll start with one of the most famous project management frameworks in the world, the Agile Methodology. So the Agile Methodology is a flexible, iterative approach to project management that prioritizes collaboration, customer feedback, and adaptability. It breaks tasks into small increments with frequent reassessment and adjustment. In Agile, projects are divided into small increments called iterations, which typically last from 1 to 4 weeks. Each iteration involves a cross-functional team working collaboratively to complete a set of prioritized tasks. Feedback from customers and stakeholders is gathered regularly, allowing for adjustments to be made quickly. Agile embraces change and encourages continuous improvement throughout the project management lifecycle. So in certain projects where you have a lot of uncertainty, such as some machine learning projects, Agile enters into direct conflict because the short time span of each iteration may be at risk of not being completed. And that leads to some tension or inconsistencies within the Agile methodology for data science. Nevertheless, when adapted to more flexibility and put into context in the machine learning world that has its own details, Agile can be a pretty useful framework to use throughout your projects. So in contrast with Agile, we have the Waterfall Methodology, which is honestly not that used today, at least in the majority of organizations, due to the fact that Agile is more able to deal with the fast-paced and complex world that we live in. Nevertheless, it's useful to know what is the Waterfall methodology and how it differs from the latter. So Waterfall is a linear project management methodology where tasks flow sequentially, with each phase dependent on the completion of the previous one. It's characterized by its structured approach, its comprehensive planning that you need to do upfront, and also less flexibility than the Agile methodology. Waterfall, you follow a linear and sequential approach to project management, and you lay out the distinct phases of the project for the long term in the beginning of the project, where you'll have initiation, planning, execution, monitoring, and closure. Each phase relies on the completion of the previous one, and there's minimal room for changes once a phase is completed. Waterfall has its downsides, as I've said, particularly in this fast-paced world, but nevertheless, the idea behind the documentation that is required for Waterfall and the fact that it's more strict than the Agile methodology, particularly thinking beforehand with a Waterfall mindset about the long-term view of the project, will help you probably narrow down certain situations that may happen during the project and that may not be useful for the completeness of it. Now, these two methodologies are probably more used on the software engineering side, and people have tried multiple times to adapt them to the data science world. They haven't been adapted in its entirety because of the particularities of most machine learning projects, but projects that have more research or where the team that is doing the project already has a lot of business knowledge and background on the problem to solve, they can be applied with higher probability of success than in other projects where there's a lot of research involved. But we also have a set of methodologies only tailored for machine learning and data science. Those are the ones that we'll know next, starting with SEMMA, methodology by the company SAS Institute, and that has stood the test of time in terms of how it has been applied in data science or data mining projects. So the SEMMA approach is a data mining methodology developed by SAS Institute, and it stands for Sample, Explore, Modify, Model and Access. So the process begins with sampling the data to ensure its accuracy in reflecting the population that you want to model. It's followed by an exploration where you understand the data's characteristics, so the typical EDA, exploratory data analysis phase, where you'll learn more about the data that you have on your hands. Next, we go for the modification, the first M of SEMMA, that involves pre-processing and cleaning the data, such as seeing outliers or treating outliers, taking care of null values, or performing feature engineering. After modifying comes the modeling phase, where you build your models or your machine learning models. And then after it, you have the assessment phase, where you validate the model's performance and usefulness, particularly against a test and a validation set. SEMMA is more used in more traditional data science projects that have tabular data. I think that SEMMA is still used today. Probably there are more versions of it coming out from the SAS Institute, but although it gives room for you to go back and explore more within the data, which is something normal in machine learning projects, it tends to be used more in cycles, in SEMMA cycles inside projects. Nevertheless, it's I think one of the first methodologies for data science and machine learning that were out there, and it's very useful and interesting to know. Now the next one is probably the most famous in the context of machine learning and data science that we'll see here, which is called the CRISP-DM. That is a very interesting way of managing data science projects, particularly because it cares about two things: business understanding and also model deployment. Things that are very important in the world of machine learning today. So CRISP-DM stands for Cross-Industry Standard Process for Data Mining. It is a widely used data mining process model that outlines 6 phases: business understanding, data preparation, modeling, evaluation, and deployment. It's a bit more abstract than the SEMMA methodology that details the tasks, while CRISP-DM details the phases of the project in terms of abstraction, so what you should take care of sequentially in a machine learning project. So these 6 phases are considered to be in iteration. So you may start with business understanding, go to data understanding, and discover something during the data understanding phase that will take you back to the business understanding, and so on. So this is something that the CRISP-DM, and that by studying CRISP-DM you learn how to do, because the framework is adaptable to that sense. So the framework is able to give room to this flexibility. So again, CRISP-DM emphasizes understanding business objectives, exploring and preparing data, building and evaluating the models, but also deploying those models in practical scenario, a project phase that is becoming more and more important as time goes by. CRISP-DM is probably the most famous and I think most used, although I don't have any survey to confirm it. It's very useful because it gives room for you to go back and forth, particularly as we discover that the data science world and data science models are very iterative, and they should be dealt in an iterative way. Now the final one is very similar to CRISP-DM, and I'll leave some link on the resources for you to compare between all these project management frameworks that I'm detailing here, and is called KDD, Knowledge Discovery in Databases. Before we go there, I want to invite you to check out my Udemy page where I teach about data science and analytics. You'll find in the description exclusive links for my SQL, Python, R courses, where you'll be able to learn how to get into the data science and machine learning world completely from scratch, and where you'll do your first steps in getting into the data world. So even with all the craziness right now in AI, understanding the fundamentals of data is one of the most important skills for any profession in the future. Knowing a bit of Python will help, knowing a bit of SQL will help. And if you just want to go down into the coding path, knowing the language will be as important as being able to generate it in ChatGPT, because you'll need to understand the fundamentals of these languages. Check out the links in the descriptions if you'd like to go through my courses. So finally, knowledge discovery in databases. So knowledge discovery in databases is a process of extracting useful knowledge from large data sets. It involves multiple steps, including data selection, pre-processing, transformation, data mining, interpretation, and evaluation. It's a bit more broad than CRISP-DM, and it's kind of more of a framework of thinking about all the data available than really a project management framework. Although it's very similar to CRISP-DM, it contains some interesting details that will be helpful for you to uncover hidden patterns and trends in the data. I'll leave some links for knowledge discovery in databases so that you can also check this framework. Okay, so one of the most important things is that you'll probably not only use one of them throughout your life in machine learning and data science. It all depends on the use case, and it all depends with the budget and time constraints that you may have. Nevertheless, knowing these 5 frameworks will be very helpful if you want to manage projects in data science, and I hope that this video has helped you at least get to know the differences on a high level between these methodologies. If you'd like to see more videos like this, subscribe to the Data Journey channel, and I'll be super happy to have you as a subscriber on this channel.